For this example, I'm assuming the random variable x is normally distributed with a mean of 100 and standard deviation of 15. I want to find the probability that x falls between 85 and 15, and the probability x is less than 112, and the probability x is greater than 95. Now, one thing to notice about this example is that x is, while it's normally distributed, it's not standard normal. For a standard normal distribution, the mean is 0 and the standard deviation is 1. So to do this, we can either convert those x values to z-scores using this formula. Z is equal to x minus mu over sigma. So I'd have to convert, for example, these two endpoints to z-scores. Then I could use the standard normal table first. For this one, I would have to plug in 12 for x and subtract 100, divide by 15, and the same thing with this. So if you want to use the standard normal table after converting your x values to z-scores, you can. A quicker way to do a problem like this is just to tell the calculator what mu and sigma are. So for part A, the probability x falls between 85 and 115, you want to sketch what's given so you're clear as to what your lower bound and upper bound are when you use the calculator. So I drew a bell curve and I want to put 100 in the middle because it's not standard normal. So 85 is below the mean. Specifically, it would be one standard deviation below the mean because 100 minus 15 is 85. And it stops at 15. So my upper bound, this is supposed to be 115. So my upper bound is 115. So I'm shading in between. So I want to find the probability of getting an x value, basically one standard deviation away from the mean. Because this is bell-shaped, previously we learned that for bell-shaped data, using the empirical rule, about 68% of the values will lie within one standard deviation of the mean. Now let's be a little bit more specific and use the normal cumulative distribution function in the calculator to actually find this area. All right, so again, if you wanted to standardize and use your z-table, you can. Okay, so to do that, for this lower bound, you'd have to take your x value minus the mean, divide by the standard deviation. Okay, so you'd get -1. Okay, so that would be your z-score. And again here, doing the same operation, we would get z is +1. So again, we're one standard deviation above the mean and below the mean. Okay, so you could standardize and use your z-table, but I'm going to go ahead and use the TI-84. So what you want to do after turning on the calculator is you want to go to your distribution menu and select normal CDF. Now my lower bound is 85. My upper bound is 115. Now because I'm not working with standard normal, I need to change mu and sigma. So the mean is 100, standard deviation is 15, and then press enter. So if you have an older calculator, in order you need to put in your lower bound, comma, upper bound, comma, mu, and sigma. And then press enter. And round it to 3 decimal places. This is 0.683. Okay, so this is consistent with the empirical rule that said about 68% of the values fall within one standard deviation of the mean. Okay, and again, you could have standardized and did this more by hand if you wanted to. I just find it a little bit more quick to use the calculator. Again, keeping in mind what your shaded area is supposed to be. All right, so for part B, the probability that we get an x value less than 112, again, I'm going to shade the appropriate area. Okay, so I'm drawing a bell curve, putting the mean in the middle, and 112 is above the mean. It's a little bit above the mean. Okay, there's my x value. And I have a less than case, so I want to shade to the left. And going to my calculator, going back to the normal CDF, that's the distribution menu. Now my lower bound is theoretically negative infinity, but there is no negative infinity key on the calculator, so I'm going to put a -1 with several zeros. My upper bound is 112, and again my mean is 100 and standard deviation of 15. Now that area, or the probability, rounded to 3 decimal places, is 0.788. I didn't draw this proportionally correct, but this is consistent with what I expected. I expected an area or a probability greater than 0.5 because I am above the mean. All right, last but not least, I want to find the probability that I get an x value greater than 95. So if you wanted to standardize and use your z-table, you'd have to recognize the fact that the z-table reads cumulatively, and you would have to subtract that area from 1, going the other direction. Okay, so to use your table, it would be 1 minus the probability x is less than 95, and you can standardize that z-score. But using the calculator, normal CDF function, we don't have to subtract from 1. Okay, so again, drawing a bell curve, something reasonably bell-shaped, putting 100 in the middle, and my x value is 95, and that is below the mean. And I want to shade to the right because I have a greater than case. Going to my normal CDF distribution in the calculator. This time I can change my lower bound to 95. My upper bound theoretically is positive infinity, so I'm going to put +1 with a bunch of zeros. Leave mu and sigma alone. And then the corresponding area or probability is 0.631. Again, I had expected this to be greater than 0.5 because I was below the mean, and shading to the right, I'm shading well over half of the curve, or well over half of the area under the curve.